All right, so we're diving deep into Amazon EC2 today.
Yeah, sounds good.
And as mid-level cloud engineers,
No.
you probably use this service quite a bit.
Yeah, definitely a bread and butter service for sure.
But we're going to go deeper,
Absolutely.
especially for those of you studying for the AWS Solutions Architect Associate exam.
For sure. Yeah, there's some good stuff here.
So this is kind of like a focused study session
Yeah, I like it.
where we unpack EC2.
Exactly.
And so let's get started.
Yeah, I'm excited.
What exactly is EC2? Why is it so important to AWS?
So, at its core, EC2 lets you rent these virtual servers
Okay.
called instances in the cloud. It's
Mhm.
kind of like having a data center at your fingertips.
Right.
Without the hassle of physical hardware.
I like that.
You can choose the operating system, the amount of processing power,
Oh,
memory and storage you need, all customized to your requirements.
So it's like building your own virtual computer,
Exactly, yeah.
but with more power and flexibility
Yeah,
than a single physical machine.
for sure.
Okay, and that's why it's considered foundational.
Yeah, for sure.
EC2 powers so many different types of applications.
Yeah, from simple websites to complex machine learning models.
Wow.
It's really the engine behind a lot of what we see in the cloud today.
Yeah, that makes sense. So it's not just one type of virtual server, right?
Right.
There's all these different
Exactly, yeah.
flavors of EC2 instances.
You get it. It's like choosing the right tool for the job.
Right.
Do you need a heavy-duty truck
Right.
or a nimble sports car?
Right.
That's the beauty of EC2.
Okay, give me some real-world examples
Yeah, sure.
of how people are actually using these different
Yeah.
types of instances.
So let's say you're a game developer
Okay.
and you have a popular online game.
Uh,
You need to be able to handle potentially millions of players
right.
connecting at the same time, especially during peak hours.
Oh, yeah.
EC2's auto-scaling features can spin up additional game servers
Interesting.
as the demand increases. Ensure a smooth and responsive experience for your players.
Even during those traffic spikes.
Exactly.
So that's how you prevent those gridded lag spikes.
Exactly.
For gamers.
That's right.
Okay, cool.
Now, on a completely different end of the spectrum,
Okay.
imagine you're a scientist working on complex climate models.
Okay.
You need massive computing power to run those simulations.
Yeah, that would make sense.
With EC2, you can create entire clusters of
Wow.
high-performance computing instances,
Yeah.
specifically designed for those kinds of workloads.
So it really does span
Right.
this huge range of applications.
It does. It's crazy.
That's
yeah.
why it's called Elastic Compute Cloud.
Exactly. It can stretch and adapt to meet a variety of needs.
Okay, so let's unpack
Yeah, let's dive in.
the core features of EC2.
Sure.
What are some of the things that cloud engineers absolutely
Yeah.
need to know about?
So instance types are a big one.
Okay.
There are general purpose instances like the T2, which are perfect for low traffic websites or dev environments where you don't need a ton of processing power. And
Right.
then you have compute optimized instances like the C5 family.
So different engines for different needs.
Exactly. Yeah.
Okay.
And then you have memory optimized instances like the R family,
Okay.
designed for handling large data sets in memory,
Uh-huh.
and storage optimized instances like the I family,
Got it.
ideal for handling massive data streams.
So it's not just about processing power.
Yeah, you got it.
There's instances tailored to all different
Shits.
types of data processing as well.
Right.
And then on top of that, you've got security groups,
That's right. Yeah.
which act as virtual firewalls,
Yeah.
controlling network access to EC2 instances.
Yeah. And elastic IP addresses, which provides static public IPs
Okay.
for your instances. So even if the underlying IP changes,
Mm-hmm.
you still have a consistent address for your applications.
I'm starting to see how these features
Yeah.
add layers of control and flexibility.
For sure.
But
yeah.
let's be realistic.
Right.
There must be some limitations to EC2,
Right?
right?
Yeah.
What are some of those?
So one of the biggest ones is cost management.
Okay.
It's incredibly easy to spin up a bunch of powerful instances
Yeah.
and forget about them, leading to unexpected bills.
Right. Yeah.
You need to be diligent about monitoring your usage
Yeah.
and choosing cost-effective options for your needs.
What about security?
Yeah, security is always a shared responsibility in the cloud.
Right.
AWS provides a secure foundation, but
Yeah.
you need to configure your instances correctly.
Okay.
So things like strong passwords for your IAM users,
Mhm.
properly configuring those security groups we talked about,
Right.
and following best practices for data protection are essential.
So we need to be proactive
Exactly.
and not rely on AWS
Yeah.
to handle everything.
For sure.
Okay. And that's where understanding how EC2 integrates
Yes.
with other AWS services becomes really important.
Yeah, absolutely. Yeah.
So EC2 isn't just this standalone service.
Wow.
It plays nicely with others in the AWS ecosystem.
It does, for sure.
Okay.
Think of it like a well-oiled machine.
Right.
EC2 can leverage services like S3 for object storage,
Uh-huh.
elastic load balancing for distributing traffic,
Okay.
auto-scaling for dynamically adjusting resources,
Right.
IAM for managing user access.
So EC2 is a powerful tool on its own,
Yeah,
but it's even more powerful
way more powerful. Yeah,
when combined with these other services.
that's right.
Okay, I think we've laid a good foundation here.
I agree.
Now let's shift gears
Let's do it.
and dive into what you came here for,
All right.
exam prep.
I like it.
Let's start with those instance types.
Sure.
There are so many options.
I know, right?
It can be a bit overwhelming.
Definitely. Yeah, we're going to break it down.
Help me break it down.
We got you covered.
Awesome.
All right.
Let's get started.
Okay. So when it comes to instance types on the exam, the key is to understand the characteristics of each instance family and match them to the requirements of the use case in the question.
Okay, that makes sense.
Like, do they need raw CPU power?
Right.
Do they need a lot of memory?
God.
Stuff like that.
But with so many families, how do I even begin to sort them out?
Yeah, it can be overwhelming for sure.
Yeah.
So think of it this way.
Okay.
If the question is talking about a scenario where cost effectiveness is really important
Uh-huh.
and the workload is light, like a simple website or a dev environment,
Okay.
you'd immediately think of the T2 family,
Okay, T2 family.
especially the T2 micro instance.
All right, so the T2 family is like the budget-friendly option.
Exactly.
Right.
For those less demanding tasks.
What about when you need serious processing power?
Yeah, then you want to go with the compute optimized families.
Okay.
So if the question's talking about raw CPU performance
Uh-huh.
for maybe some batch processing or running some high-performance applications, you'd think about the C5 family.
Okay, the C5 family.
They're designed to handle those CPU-intensive workloads.
Got it. So T2 for cost effectiveness,
Yep,
C5 for raw CPU power.
exactly.
Are there any other families I should be keeping in mind for the exam?
Yeah, for sure.
Okay.
The M4 family is a great all-rounder.
Okay.
It offers a good balance of compute, memory, and networking capabilities.
Okay, so they're kind of like the in-between.
Yeah, exactly.
Right.
They're a popular choice for things like web servers, application servers,
Okay.
and just general purpose workloads.
So the M4 is like the reliable workhorse of the EC2 world.
That's a good analogy. I like it.
Okay, so we've got T2 for cost effectiveness,
Yep.
C5 for CPU power,
Yeah,
and M4 for general purpose.
that's right.
Now, what if the exam throws me a curveball
Okay, I like it.
and I need an instance with a lot of RAM?
Yeah, for sure.
Is there a specific family for that?
Absolutely.
Okay.
That's when you'd look at the R family.
Okay.
They're designed for memory-intensive workload.
Okay, like maybe a real-time analytics application.
Exactly. Yeah, good example.
Okay.
And they come with a high ratio of memory to CPU cores.
So if you need to handle large data sets in memory,
Yeah,
our family,
that's it.
this is starting to feel a lot more manageable.
Good. I'm glad to hear it.
What about storage?
Yeah, so for storage,
If I need to handle these massive data streams,
right?
is there a family for that?
Yeah, you'd want to look at the I family.
The I family.
They're optimized for high sequential read and write performance.
Okay, so they can handle a lot of data coming in and going out.
Exactly.
Okay, so to recap, we've got T2 for cost effectiveness,
Yep.
C5 for CPU power,
Sure.
M4 for general purpose,
That's right.
R for memory-intensive workloads,
Yeah,
and for storage optimized tasks.
you got it.
Is there anything else we need to know about instance types on the exam?
Yeah, so those are the main families.
Okay.
But remember, each family also has a range of instance sizes.
Okay, so like small, medium,
Eh.
large.
Exactly, yeah. So from small to extra large, offering different combinations of CPU cores, memory, and storage capacity.
So the exam might ask about a specific instance size.
Right, they might get really specific and say
Right.
which instance size within this family would be best for this scenario.
Got it.
So you need to understand how those vCPUs, the memory, and the storage capacity all relate to each other.
Okay, that makes sense.
Yeah,
So it's not just picking the right family, but also the right size.
exactly, exactly.
Okay, so let's move on to another important topic for the exam.
Sounds good.
Pricing options.
Okay, yeah.
Can you walk me through how to approach those questions?
Yeah, for sure. So AWS offers several different pricing models for EC2
Right.
to kind of meet different needs and budgets.
Okay.
And so on the exam, you'll likely be asked
Yeah.
to recommend the most cost-effective option
Okay.
based on whatever's in the question.
Got it.
So it's really all about understanding the trade-offs between the different pricing models.
Okay, so let's start with on-demand instances. Okay, yeah.
When would those be the best choice?
So on-demand instances offer the most flexibility.
Okay.
You pay for what you use by the hour or even by the second
Mm,
with no long-term commitments.
okay.
So they're great for short-term, unpredictable workloads.
Okay. So it's like paying for a rental car.
That's a good analogy.
Use it when you need it and return it when you're done.
Exactly.
Okay. What about reserved instances?
Yeah, so reserved instances are more like purchasing a car.
Okay.
They offer a significant discount compared to on-demand,
Mm-hmm.
but you commit to using a specific instance type
Okay.
for a 1 or 3-year term.
So you're locked in,
You are, yeah.
but you get that discount.
You get a big discount.
Okay.
So those are best for applications where you have steady state usage.
Okay. So you can confidently predict your long-term needs.
Exactly.
Yeah.
So you know what you're going to need and you're going to use it for a while.
Makes sense.
Reserved instances are the way to go.
All right. On demand for flexibility.
Reserved instances for long-term commitment and cost savings.
Exactly.
Now, what about spot instances?
Spot instances.
Aren't those the really cheap ones?
Yeah, they are.
But you can lose them.
You can.
Yeah.
So with spot instances, you're basically bidding on spare EC2 capacity,
Wow.
and you can get them at a much lower price.
Like up to 90% cheaper, right?
Yeah, up to 90%.
Wow.
Yeah, it's a big discount.
Okay.
But the trade-off is that if your bid gets outbid,
Yeah.
your instances can get terminated.
With very little notice.
2 minutes?
2 minutes.
Yeah, you get a 2-minute warning.
So it's like finding a great deal on a flight,
I like that analogy.
but you might get bumped
Exactly.
if someone else is willing to pay more.
Exactly.
So when would those be a good option?
So they're best for fault-tolerant applications or flexible applications
Uh-huh.
where interruptions aren't a big deal.
Okay, so maybe like batch processing jobs
Exactly.
where you can just restart them
Yep.
easily.
Or stateless web servers,
Oh,
things
good.
that can be easily restarted.
So spot instances are for the bargain hunters
Yeah.
and those who can handle a bit of unpredictability.
Right. That's a good way to put it.
All right, so we've covered on-demand,
Mm-hmm.
reserved,
Yeah.
and spot instances.
Yeah.
Is there anything else we should keep in mind about pricing options?
Yeah, don't forget about savings plans.
Okay, savings plans.
Yeah.
What are those?
So they kind of combine the cost savings of reserved instances
Okay.
with the flexibility of on-demand.
Okay, how do they do that?
So you're basically committing to a consistent amount of compute usage
Uh-huh.
over a 1 or 3-year term,
Okay.
but you don't have to choose specific instance types.
So it's like buying in bulk, but you don't know what you're going to get.
Yeah, kind of.
Okay.
You're just committing to that level of usage.
All right, so it's for customers who have consistent usage,
Yeah,
but they might not know what they're going to need.
exactly. A year from now.
Okay, so savings plans for that kind of situation.
Yep.
All right, that covers the main pricing options.
It does.
What other topics related to EC2 might pop up on the exam?
Yeah, placement groups are a big one.
Placement groups.
Yeah, they let you control where your instances are placed,
Okay.
either within an availability zone or across availability zones,
Okay.
so that you can optimize for either performance or availability.
Okay.
So, for example, cluster placement groups are great for low latency communication between instances.
Right.
So those are often used for things like high performance computing,
Sure.
big data processing,
Right.
or other applications where latency is a concern.
Cluster placement groups for speed.
That's it.
What other types of placement groups are there?
Yep, there are also partition placement groups
Okay.
and spread placement groups.
All right. Tell me about partition placement groups.
Yeah, so partition placement groups spread your instances across different partitions
Okay.
within an availability zone. This helps to ensure that if one partition fails,
Right.
your application can still run.
Okay, so you're minimizing the impact of a potential failure.
Exactly, yeah.
What about spread placement groups?
Yeah, so spread placement groups are similar,
Okay.
but they work across availability zones.
So instead of spreading within a single availability zone,
Right.
you're spreading across multiple availability zones
Exactly.
for even more redundancy.
That's right.
Okay, so cluster placement groups for low latency,
Yeah.
partition placement groups for high availability
Uh-huh.
within an availability zone,
Right.
and spread placement groups for high availability across availability zones.
You got it.
Got it.
Awesome.
What other EC2 concepts should I brush up on for the exam?
Security groups.
Okay. Yeah, those are
Yeah,
important.
you need to understand how to configure them
Right.
to control traffic to your instances.
So like allowing SSH access only from specific IP addresses.
Exactly. Yeah, good example.
Okay, so I need to practice my security group configurations.
Yeah. For sure.
What about elastic load balancing?
Yeah, so elastic load balancing, or ELB,
Yeah.
is a service that distributes incoming traffic across multiple instances.
So if I have a web application
Yeah,
running on multiple instances,
right.
ELB makes sure that the traffic is spread out.
Exactly.
Yep.
And it also makes sure that if one instance fails,
Right.
the traffic is redirected to the healthy instances.
Got it. So it helps with high availability and scalability.
For sure.
Okay.
So on the exam, they might ask you to choose the right type of load balancer.
Okay, so there are different types of load balancers.
Yeah.
Like what?
Like an application load balancer for HTTP and HTTPS traffic,
Right.
or a network load balancer
Okay.
for TCP and UDP traffic.
So I need to know the difference between those.
Yeah, you need to know when to use which one.
Okay.
And you might also be asked about health checks.
Health checks.
Yeah, those determine if an instance is healthy
Right.
and only route traffic to healthy instances.
Yeah. Okay, so the load balancer is constantly checking
Exactly.
on the health of the instances.
That's right.
Or what about auto scaling?
Yeah, so auto-scaling works with ELB
Okay.
to basically make sure that you have the right number of instances running
Yeah.
based on demand.
So if traffic suddenly spikes,
Yeah,
auto scaling will spin up more instances
exactly.
to handle that traffic,
That's right.
and then it'll scale back down
Yeah.
when the traffic dies down.
Exactly.
Uh-huh.
And on the exam, they might ask you to configure auto-scaling policies
Okay.
based on different metrics.
All right. So like CPU utilization or network traffic.
Yeah, exactly.
Okay, this is starting to come together.
Awesome.
Now, we haven't talked much about EBS volumes.
Yeah, EBS volumes are important too.
What do I need to know about those for the exam?
So EBS volumes give you persistent block storage for your instances.
Okay.
So it's kind of like having an external hard drive
Yeah, okay.
for your instance.
Got it.
And you can store data that needs to stick around.
Even if the instance gets terminated.
Okay, so what types of EBS volumes are there?
Yeah, so there are a few different types.
Okay.
But the two most common ones are GP2 and IO1.
Okay, GP2 and IO1.
Yeah, so GP2 is a general-purpose SSD volume
Okay.
that offers a good balance of price and performance.
So that's kind of your default option.
Yeah, you could say that.
Okay.
And then IO1 is a provisioned IOPS SSD volume.
Okay, what does that mean?
So that means you can specify exactly how much IOPS performance you need.
Okay.
And it's designed for workloads that require consistent high performance.
Like databases.
Exactly, yeah. Good example.
Okay, so GP2 for general purpose.
Yep.
IO1 for high performance.
You got it.
Anything else?
Yeah, don't forget about encryption.
Encryption.
Yeah,
Okay.
you can encrypt your EBS volume.
Right, to protect the data.
Exactly.
Okay.
So on the exam, they might ask about encryption
Got it.
and how to set it up.
Okay.
All right, and the last thing I wanted to touch on.
Was NAT gateways and NAT instances.
Okay, NAT gateways and NAT instances.
Yeah.
How might those be relevant for the exam?
So they allow instances in a private subnet
Okay.
to connect to the internet,
Right.
but without having public IP addresses.
Okay.
So it's a security thing.
Right. You don't want those instances exposed
Exactly.
to the public internet.
You got it.
Okay, so they're like intermediaries
Yep.
that allow the private instances to initiate outbound connections,
Right.
but they're not directly accessible from the outside world.
That's right.
Okay.
And so on the exam, they might ask you to set up a NAT gateway or a NAT instance.
Okay, to enable internet access for those private instances.
Exactly.
All right. I will definitely brush up on my NAT gateway and NAT instance knowledge.
Sounds good.
This has been a really helpful overview
I'm glad to hear it.
of all the different EC2 concepts
Yeah.
that might pop up on the exam.
For sure.
Anything else you'd like to add?
Yeah, just remember, practice makes perfect. So the more you familiarize yourself with these concepts and work through practice questions,
Yeah.
the more comfortable you'll be on exam day.
Great advice.
Thanks.
I'm definitely feeling more prepared now.
I'm glad.
All right. Okay, so we've covered a lot of ground with those core EC2 concepts, but I have a feeling there's more.
Oh, yeah, definitely.
What are some of those advanced EC2 features
Yeah, for sure.
that might give me an edge?
So let's talk about Elastic Fabric Adapter, or EFA.
EFA.
Yeah.
Okay, I'm intrigued.
So imagine you're working with high-performance computing applications that need really low latency communication between instances.
So like tightly coupled workloads
Exactly.
where even a tiny delay can really mess things up.
Yeah, exactly.
Okay.
So EFA is basically a special network interface
Uh-huh.
for EC2 instances
Okay.
that gives you that ultra-low latency communication.
And how does it do that?
So it kind of bypasses the operating system's network stack and allows for direct communication between instances at the hardware level.
So it's like a dedicated express lane for data
Yeah, that's a good way to think about it.
between those high-performance computing instances.
Exactly.
Wow, that's pretty cool.
It is, yeah.
Okay, so EFA for high-speed communication.
Yep.
What else?
So let's talk about placement groups again.
Okay, yeah, we talked about cluster, partition, and spread placement groups.
Right.
But are there more?
There are a couple of more specialized types that you might see on the exam.
Okay, like what?
So dedicated placement groups and host affinity placement groups.
All right, what are those all about?
So dedicated placement groups are for when you need complete isolation.
Oh, wait,
So your instances are the only ones on those physical servers.
so no noisy neighbors.
Exactly, yeah.
Okay,
So if you have an application that has strict regulatory requirements,
right.
or maybe you just want to make sure that the performance is super predictable,
Uh-huh.
dedicated placement groups are the way to go.
Okay, and what about host affinity placement groups?
Yeah, so those give you even more control
Okay.
over where your instances are placed.
How so?
You can actually choose which dedicated host your instances run on.
So if I have specific licensing requirements
Yeah, exactly.
that are tied to physical hardware,
Right.
or if I need certain instances to always be together,
Yep.
host affinity is the way to go.
Oh, got it.
Okay, so dedicated placement groups for isolation.
Huh?
Host affinity for fine-grained control.
That's right.
Okay, got it.
Awesome.
Now let's talk about security.
For sure.
We touched on security groups, but what about actively detecting intrusions?
Yeah, so for that you would use AWS Guard Duty.
Guard duty.
Yeah, it's like a security guard for your cloud environment.
Okay, what does it do?
So it uses machine learning and anomaly detection
Okay,
to identify threats.
so it's like constantly looking for suspicious activity.
Exactly, yep.
Okay.
It can detect things like unusual API calls,
Uh-huh.
attempts to access sensitive data, or communication with known bad IP addresses.
So it's like having an extra set of eyes.
Yeah, that's a good way to put it.
Okay.
And it can also help you respond to incidents really quickly.
Okay, so guard duty for threat detection and response.
Exactly.
Got it. Now what about compliance?
Yeah, compliance is important too.
How do we make sure that our EC2 deployments are meeting all the regulatory requirements?
So AWS has a whole suite of tools to help with that.
Okay.
One of the key ones is AWS Config.
AWS config.
Yeah.
Okay, tell me more about that.
So it's basically a configuration management system
Uh-huh.
for your entire AWS environment.
Okay.
So it keeps track of all your resources,
Right.
what they're configured like,
Okay.
and it helps you make sure that you're following best practices.
So it's like a detailed audit trail for our cloud infrastructure.
Yeah, exactly.
Okay.
And it can also automate some remediation actions.
Okay, so if there's a problem,
Yeah,
it can help us fix it
Right.
automatically.
exactly.
Okay, so we've got guard duty for security.
Yep.
AWS config for compliance.
hmm
Any other essential services?
Don't forget about AWS budgets.
Okay, AWS budgets.
Yeah, might not seem directly related to EC2,
Right.
but it's super important for managing your costs.
Okay, and how does AWS budgets help with that?
So you can set spending limits for your accounts,
Okay.
track your usage against those budgets,
Right.
and get alerts when you're getting close to your limits.
So it's like a financial advisor
Yeah, exactly.
for our cloud spending.
I like it.
Okay, that's a good analogy.
It is.
Any other parting words of wisdom?
Yeah, just remember that this is just the beginning.
Okay.
The cloud is constantly evolving.
Right.
So just stay curious, keep learning,
Yeah.
and keep experimenting.
That's great advice.
Thanks.
I feel like I have a much stronger foundation in EC2 now,
Awesome.
and I'm excited to keep learning.
You too.
So to all of you cloud enthusiasts out there,
Yeah,
keep learning, keep building, and keep pushing the boundaries of what's possible in the cloud.
that's right.
Until next time, happy clouding.
Happy clouding.